Today we are only going to be tackling one problem using trigonometry and angles of elevation and depression. Right now, we're dealing with aerospace, and on July 20th, 1969, Neil Armstrong became the first human to walk on the moon. During this mission, Apollo 11 orbited the moon 3 miles above the surface. So I want you guys to understand right now that we have a certain distance right here. That distance right here is how high above the moon's surface?
3 miles.
3 miles. That's going to stay consistent in our problem. Okay? Now, at one point in orbit, the onboard guidance system measured the angles of depression to the far and the near edges of a large crater. So right here, I want you to pay really close attention to from here to right here. Now, this angle is dealing with what? The near part of the crater. And this angle over here is dealing with the far side of the crater. Now, I don't know if you guys can see this. Can you guys see this crater right?
Oh, okay.
And then can you guys see it?
Yeah.
All right, so this is a crater right here. So it says the angles measured 16 degrees. Now this 16 degrees, everybody, is right in here. This is 16 degrees. Okay. And then 29 degrees is this angle right in here. That's 29 degrees. What's the purpose of this particular problem? What are we trying to find? The distance across the crater. So right now, if you would, make a mental note that we're trying to find this distance from here to right there. We're trying to find that distance. Now, what I'm going to do is I'm going to separate two triangles. So can you guys see this small, I'm tracing it right now. You guys see that triangle right there? What I'm going to do is I'm going to create that triangle right here. Okay? So that's this triangle. Now, I'm going to trace the other triangle right here. You guys see this triangle I'm tracing? Okay? So I'm going to make that triangle. Just going to make it a little bit longer. Okay? Now, right here, my right angle is right there. My right angle is right there. What's the distance from here to here in both cases? 3, so put 3 miles. And put 3 miles. Now, in this problem, we have two angles that we have to worry about. Does everybody see this 29-degree angle right there? That's going to be the same as this because those are alternate interior angles. So this angle right in here, what am I going to put as the measure of that angle? Put 29 degrees. This 16-degree angle right here is the same as this angle right down in here. So right in here in this little corner, I'm going to put 16 degrees. This is the angle of depression. This is the angle of elevation. This orange angle right here, the 29 degrees, that's the angle of depression. This is the angle of elevation. Right. Now, everybody, the next thing I want you to do is the distance from here to here is called N. So I'm going to label that N. The distance from here all the way across is F. So I'd like you to put F. The distance of our crater, which is from here to here. So I'm going to put the word crater right here. The length of the crater is going to be whatever the distance of F is minus the distance of N. So what do we have to find? We have to find F, and we need to find N, and what are we going to do? We're going to find the difference between them, and that's going to be our answer. Now that I have these triangles side by side, now I'm going to start the process. The very first thing that you always notice me doing is I always put an arrow going across, which allows me to label my opposite side. Okay. This side right here is going to be my hypotenuse, which means the lowercase n, that distance, is considered to be my adjacent side. Now, what information do I have? I have the 29-degree angle. What else was given to me? I was given my opposite side, so I'm going to put a big old capital O right there. And what am I trying to find? Nope. My adjacent side, so I'm going to put capital A right there. Okay. So you see the O and the A, and that's exactly what I want you to think. I want you to think, oh, that means I have to use tangent. to solve, right now we're going to solve for n. So we're going to write tangent of the measure of a particular angle. So the tangent of what angle? 29. And that is equal to the opposite side in relationship to the adjacent side. So what is the length of my opposite side?
3 miles.
3 miles. Very good. And the length of my adjacent side that I'm looking for, I'm going to put the letter in. So now, what have we set up? We've set up our equation. There's our equation all set up. Now, whenever I'm solving the equation, my strategy that I'm trying to pass on to you to make it a little bit easier, just put it over a 1.
And then 3.
Then you put 3 over n. Now you're going to cross multiply. Now, by the way, when you get to this part, you need to ask yourself, is this going to be the hard way or the easy way? Because where's my variable? It's in the denominator. Whenever it's in the denominator, you always have to go that one extra step. So look what happens when you cross multiply. When you cross multiply those, you get n times the tangent of 29 degrees equals the product of 3 times 1, which is 3. So we're not done with our problem, because what are we trying to find? We're trying to find the distance to the near side of the crater, which is that's the letter n. So what do we have to do to both sides to solve for n? We have to divide both sides by the tangent of 29. 29 degrees. So we're dividing 3 by the tangent of 29 degrees. And that right there, everybody, I'm not going to put it in my calculator yet, but that's one piece of information that I'm going to need. Everybody, this is considered to be the exact distance. We're going to find the approximate value here in a little bit. We're going to just write that down. Now the next thing we're going to do, I'm scrolling up a little bit. You need to pause. Right here. Now I'm going to be solving for f. Would you guys agree? It looks like the exact same problem, right? What's the only difference? The 16 degrees instead of the what? 20. That's it. So I'm going to set up the exact same way. We have all the exact same pieces. Is this still my opposite side? Yes. Is this still the hypotenuse? Yes. Is this still the adjacent side? Absolutely. So this is what we have. This is what we need to find. So I'm going to set up everything the exact same way. But the only thing that's changing is what? The measure of the angle. That's the only difference. See how similar these two are? It's the same process. The only thing that's changed is, the 16 degrees. So you really don't, once you realize it, you really don't have to do this. You don't have to set it like this. Honestly, you should know that the answer is going to be 3 divided by, not the tangent of 29, it's going to end up being 3 divided by the tangent of 16. Now, I'm showing you the process, but that's, if you see the same pattern, you can skip a step. So what is n? After you do all that work, what's n going to equal? It's going to be 3 divided by the tangent of, I'm sorry, not n, I meant to put f, I apologize. I was setting up the exact same way, but this represents f, not n. Oh well. Better to catch it now. I'll scroll back up. I just forgot to put f, I just kind of used the letter n. But f, remember, f is this distance from here to here. So what's our exact answer for f? 3 divided by the tangent of 16. Now it's going to be important right now that when you do this, make sure that your mode, make sure you are not in radian mode. Make sure you go down and change it to degree mode. Make sure you're in degree mode. There we go. And then you're going to do 3 divided by the tangent of 29. And that's our answer for n. And 3 divided by the tangent of 16 And that's our answer for F. So the gap between these two, the gap between those two distances is going to end up being our answer.
Can we round it?
Yeah, we will, but we're not going to round it until the very end.
Okay.
Okay, so what we're going to do is, let's take the bigger distance right here, which is F. Let's take away the smaller distance, which is this. And you can see your answer is 5.05. Now, I didn't tell you to round to the nearest tenth. We're just going to round to the nearest tenth. If they never tell you to round to, say, 100th or 1,000th, just always round to the nearest tenth. Okay? So we're going to put 5.1 and make sure you label it miles. It's 5.1 miles. Now, what does that mean? That means the distance of this crater from this side of the crater all the way to the other side of the crater. What is that distance? 5.1 miles. That is a large crater. Okay, over 5 miles long.
Oh, you wouldn't even know you were in the crater.
So that's
Yeah,
pretty amazing right there.
Wait,
Okay?
5 miles like.
The distance all the way across.
It would just be like, why is it so uphill?
Yeah. So from up there, you could probably say, "Ooh, I wonder how big that, I wonder how long that is." Well, how can you find it? Using trigonometry.